Alright, this is the first version of this, so I'm gonna, I don't know, give me some feedback on whether this is useful or not, or whatever. In class, I want you to give me feedback. I'm gonna do these along, so if you got confused, maybe it helps to hear things a second time, and instead of just looking at a solution guide, maybe this is a more live version of a solution guide. Okay, so derivatives of inverse trigonometric functions. 3, we're going to find dy over dx two ways. Make sure you use dy dx, not y prime, just because I asked you to. We're going to get rid of the inverse trigonometric function and then use implicit differentiation. Let's call that the long way, the triangle way, whatever. And then by using the rules we created yesterday. And again, hopefully you're starting to memorize these rules, but that's probably fleeting. So we take sine of both sides, and we'll end up with sine of y is equal to sine of inverse sine of 2x, which will just simplify to 2x. The derivative of sine of y is cosine of y, chain rule, dy dx, and the derivative of 2x is 2. So dy dx is 2 over cosine of y. And in order to figure that out, if you don't know already, we should probably draw a right triangle. And that angle is going to be y is inverse sine of 2x. So we just need some ratio where if we take sine of our angle, we get 2x. I'm going to use 2x over 1, 2x on the opposite side, 1 on the hypotenuse. And the adjacent side is 1 minus 4x squared. Just using Pythagorean theorem. And let's see. Oh, okay. All we have to do is dy dx is equal to 2 over, and then cosine of y gets replaced with the square root of 1 minus 4x squared. I suppose over 1, but we don't need to bother writing over 1. Okay, so the other way to find the derivative of inverse sine, let's see, dy dx is the derivative of inverse sine is 1 over the square root of 1 minus the input squared. Our input is 2x, which has a rate of change of 2. So dy dx is 1 times 2 is 2, over 1 minus 2 times 2 is 4, x squared. Cool, they match. Alright, let's try that again. Y is equal to inverse tangent of 3 over x. Hopefully you're noticing, oh, not dy dx, darn it, that these are awfully similar to what we did in class. Okay, so tangent of y is equal to 3 over x when we take tangent of both sides. The derivative of tangent y is secant squared y, chain rule, dy dx. And hopefully by now you've memorized the derivative of 1 over x, negative 1 over x squared. So the derivative of 3 over x is negative 3 over x squared. So dy dx is negative 3 over x squared secant squared y. Let's think about our side lengths. Let's see, inverse tangent of 3 over x goes here. And opposite side 3. Adjacent side x, and the hypotenuse is going to be the square root of the sum of x squared and 3 squared. Okay, so we'll just get everything that we know is going to be in our derivative, negative 3 over x squared, and we're going to square whatever we get out of secant. Secant of this y is hypotenuse over adjacent, so this square root of x squared plus 9 over x, and negative 3 over, well, you know, this x right here is going to get squared, so it'll divide out with the x out front, and we'll be just left with squaring that square root, so x squared plus 9 in the denominator. Okay, so how do we do that I've memorized the derivative way? The derivative of inverse tangent of something is 1 over 1 plus that something squared. Our something is 3 over x, which has a rate of change of negative 3 over x squared. Okay, so let's simplify a little bit. And negative 3 times 1 is negative 3 in the numerator. X squared times 1 in the denominator is x squared. And then 3 over x when you square it is 9 over x squared. Times x squared just simplifies to be 9. Cool, they match. Hopefully it's taking you 5 minutes to do this as well. My guess is no. Okay, so do we remember the derivative of inverse secant? It's the one with the absolute value. It doesn't tell me, so I'm going to find y prime. Okay, so the derivative of inverse secant is 1 over the absolute value of normally x, but let's say input, times the square root of the input squared minus 1. And that input is 5x, so that 5x goes in both spots, which has a rate of change of 5. So y prime is 5 over. We can actually divide out with the absolute value. We'll do that in a second. And the square root of 25x squared minus 1. And so, the absolute value doesn't affect division of 5 over 5. The absolute value really affects just that x there. So we might as well have the simplified version, 1 over the absolute value of x, square root of 25x squared minus 1. All right, the derivative of inverse cosine of something is negative 1 over the square root of 1 minus the input squared. This input is 2x minus 3, which has a rate of change of 2. Negative 1 times 2 in the numerator is negative 2. And we should probably multiply that out. Square root of 1 minus 4x squared minus 12x plus 9. And so y prime, negative 2 over, let's see, we'll do negative 4x squared, and then a plus 12x, and a minus 9 plus 1 is minus 8, and let's not forget that square root. Oh, darn it. We should probably simplify a little bit more. Okay. So y is equal to negative 2. Every single term in that square root has a 4. So we can take the square, factor out that 4, and then its multiplication. So take the square root of that 4 to get a 2, and we'd be left with negative x squared plus 3x minus, I don't know why that's so hard too. Uh-oh, pen has died. Back at pen. Oh no, I lost my prime. So y prime is negative 1 over the square root of negative x minus 2x minus 1? I think that's right. Cool. Alright, so the derivative of inverse cosine of something is negative 1 over the square root of 1 minus that something squared. That something is 1 over x, which has a rate of change of negative 1 over x squared. And so negative 1 times negative 1 is 1. And I'm going to multiply, what am I going to do here? I'm not really sure. Okay, so maybe we bring that x squared inside the square root. That x squared inside the square root would be an x to the 4th. So that's 1 minus 1 over x squared. Right, does that work? Yeah, the square root of x to the 4th would be an x squared. Okay. So y prime is 1 over the square root of x to the 4th minus x squared. That's probably not the best way to do that. Let's go back and change this. Let's keep one x outside and have an x squared in here. So x times the square root of x squared minus 1. I think that looks so much better. Okay. The derivative of inverse tangent of something is 1 over 1 plus the input squared. That input is 2x minus 3, which has a rate of change of 2. So 2 over 1 plus 4x squared minus 12x plus 9. The reason we are simplifying or rearranging is that denominator is not simply multiplication. Another reason is you'll have to break this down in reverse eventually, and so hopefully, I don't know, maybe you could realize 4x squared minus 12x, oh my gosh, maybe I could do something there. This is in the future if that was a 9 instead of a 10, that sort of thing, because we're going to have to work backwards. Antiderivatives. Ooh, this looks gross. Oh, I get why you guys don't like homework. Okay, the derivative of 2 something is 2 times the derivative, and the derivative of inverse sine of something is 1 over, but I already have a 2, so 2 over the square root of 1 minus the input squared. That input is, ooh, that's kind of cool, a square root of 1 minus 2x squared. The derivative of a square root is 1 over 2 times that square root. And inside that square root is a 1 minus 2x squared, which has a rate of change of negative 4x. Yeah, that was kind of fun. Okay, so I'm going to divide out the 2 and the 2. So my numerator is just going to be negative 4x. And I have 2 square roots to deal with. I think I'll keep them in order. Okay, so 1 minus... square the square root and we get 1 minus 2x squared. And the other square root is 1 minus 2x squared. Oh, that's kind of cool. So square root 1 minus 1 is 0, minus a negative 2x squared is simply a 2x squared times the square root 1 minus 2x squared. And we can definitely divide out an x. So that's going to be negative 4 over square root. I might as well bring the 2 into the other one. 2 minus 4x squared. I think that's probably the best way to go. Okay. The derivative of inverse secant of 3x squared is 1 over. You know what? Let's not write the 1 there. I'm going to do my chain rule on top at the end. The absolute value of the input times the square root of the input squared minus 1. That input is 3x squared, which has a rate of change of 6x. Alright, now you might think we can drop the absolute value. And can we? I think we can because 3x squared is always positive. We might get a negative out of 6x, and so let's think about this. 6 divided by 3 is definitely 2. And if I just had an x down here out front, I think that works out the same. You know, if I had, I don't know, let's say negative 3, 6 times negative 3 over 3 times negative 3 squared in an absolute value, is that the same as 2 over simply negative 3? Well, overall we'd get a negative, so no problem, and the rest of the math works out. Yeah, I think that's good. Okay, and then here, 9x to the 4th minus 1. Cool. The derivative of arcsine, the derivative of inverse sine, is 1 over the square root of 1 minus the input squared. That input is 1 minus x, which has a rate of change of negative 1. I'll simplify that, and that's going to be, let's leave some parentheses, 1 minus 2x plus x squared. 1 minus 1 is 0, so 2x minus x squared. Cool. Is that all? Oh, dude, that was so easy. 15 minutes, 9 seconds.